Hello students. So in this lecture I will discuss about the longitudinal mode separation. So let's start this lecture. So what is longitudinal mode separation? Longitudinal mode separation is defined as the difference of frequency between a consecutive modes. What I mean is to understand that to derive the formula for longitudinal mode separation and understand the meaning of optical cavity, we first understand what is ruby laser. So if you consider this is a ruby laser, you may take any other laser. See, this is the ruby laser, this is xenon lamp to provide optical excitation. Now see, this material in case of ruby laser is made up of aluminum oxide or chromium oxide. This is the xenon lamp to provide the optical excitation. Now as this will be excited, inside this is called optical cavity. Optical cavity. See, then in this region photons will be generated which are coherent, that they are moving in same direction, also in same phase. So inside this optical cavity, what will be stimulated emission will take place. So photons will be generated and they will travel. This side is partially silver and this is fully silver. So photons cannot exit from this side. So there is some penetration, means before coming very strong, only a very strong intensity photon can pass through it and that will observe the laser at this point. See, once the photons are generated, these are generated due to stimulated emission. See, and these photons will strike this because this is partially silver side. So photons cannot, until unless they do not have very high intensity, they cannot come out of this cavity. So when photons will be generated, they will strike this surface and move back. So inside this cavity, standing wave will be generated. There will be alternate nodes and antinodes will be present in this cavity. This is called optical cavity. Suppose L is, I am taking L is the length of optical cavity or cavity length. Now we have to derive the formula for longitudinal mode separation. So see, what is time? Time is nothing but distance upon speed. How much distance the photons travel before coming out of the laser? So distance traveled by this is first L and then it will trace twice. So total distance covered by photon is 2L divided by speed. What is the speed of light? If the refractive index of material, if it is a gas, refractive index will be considered, can be considered to be 1. Suppose mu is the refractive index of this medium. So speed is nothing but that is C divided by mu. So speed of a light in this medium or a photon in this medium. So C by mu. So time will come out to be 2L mu divided by C, where L is the optical cavity length, C is the speed of light, mu is the refractive index of this medium. We have to calculate the frequency, that is longitudinal mode frequency. So which is given by, so frequency is nothing 1 by or the reciprocal of time. So what is time? So if you take a reciprocal, you will get C 2L by mu. So this is the frequency or the longitudinal mode frequency or difference of frequency between the consecutive modes. So this is our formula for longitudinal mode separation. Mode separation. Now, next, number of modes. How many modes will be generated? So to calculate the number of modes, we have a formula like bandwidth is the total frequency from difference of higher frequency to lower frequency. That frequency band is nothing but a bandwidth divided by longitudinal mode separation, that is mu. So this is generally denoted by separation mu. So this is longitudinal mode separation or the difference of frequency between the consecutive modes. So number of modes is bandwidth divided by Longitudinal mode separation. Thank you.